Hello, welcome to the latest episode of Data in the Hallway. Here with my co-host Daniel, joining from Amsterdam, and excited to welcome Adam from Metis. He's a head of DevRel. Adam, let me just give you welcome, give you a chance to introduce yourself and tell us a little bit about Metis and what you folks do.
So, hello everyone, thank you for tuning in. I'm Adam, currently head of the at Metis, also software engineer for like nearly 15 years, doing tons of stuff, front and back and mobile. You can easily Google me up. I'm also a blogger, public speaker, so there is tons of my videos on YouTube and whatnot. And when it comes to Metis, this is a very good question, what we do. We built a thing that we call database guardrails. We built a completely new solution that let developers own their databases. Own in this true sense, that they finally have the tooling that lets them debug all the performance issues, understand what's going on behind the scenes, and finally gives them actionable insights. Not something that is like, swamping them with raw metrics or with data that you see on those fantastic colorful dashboards, but actually straight to the point insights telling you that, hey, this query is slow. This is because you deployed this change and now your data access pattern was modified since last week. So you need to go into this place and fix your code this way. This is what we want to achieve, not something like give you all the data which you have no idea what to do about, but give you very direct insights that if you want to understand the data, sure, we'll give you everything you need. But if you want to understand the outcome, we connect all the dots for you.
Cool. Awesome. So yeah, so the theme of this episode is, a lot of what you said, Adam, is helping database and application developers make sure that their applications actually not only work but actually scale and work in the long term. So what are some of the? This might be a pretty basic question for a lot of database developers, but what are some of the typical challenges that people face as they're thinking about developing a new database applications? What are some of the things that you typically see as you work with your customers and even from your previous developer background?
Yeah, this is actually a very good question because it seems like we should all know what goes wrong, but let's actually name these things so we see the clarity. And I believe there are generally three main parts of what can go wrong and how we need to address them. Those are like prevention, those are like monitoring, and finally troubleshooting. So let's walk through those things like one by one from the developer perspective, right? I'm talking about the developers mostly, although like when we are DevOps or platform engineers, then obviously we see the same issues, but we look at them from a little different angle. So first thing is prevention. Like developers, we as developers, we write code. We want to just implement the business logic and then deploy that to production, right? But when we find there is an issue, it takes us a lot of time to fix that when we find this issue like very late in the pipeline, right? We want to push all those checks to the left. And we are told that, hey, CI/CD is the solution, unit testing is the solution to fix all the issues. But then we realize it doesn't work like that. You don't see problems with n+1 queries. That's one issue that developers often face, right? So you have two tables with a join between them. You use some ORM, which is object relational mapper, so library which maps database objects to your language objects. And then when you try to access some properties, this library basically needs to go and extract additional rows because you joined two tables, right? So if you are running that in your local environment and you have the so-called lazy mode enabled, so you don't join the tables in one query, but you fetch those rows one by one, then you will have n+1 queries in total. But you won't see the problem. The performance of your local database, especially if you have something like, 100 rows in your local database, you will never see the problem because it's going to be fast enough. You won't see the issues with unit tests because, well, you return correct data. It's just the way how you get this data is something that you will figure out only when you deploy to production, or if you have load tests in place, then at the very end of the pipeline, you'll figure out there is a problem, right? And this hampers developer experience significantly, right? Because we as developers, we are typing the code and we learn about the issues much, much later. That's one of the problems. Other problems is, what about our database configuration? Is my query using indexes? Again, if I'm running on local database, probably not a problem at all because I have 100 rows. So even though I don't have an index, it's still gonna be fast enough. Once I go to production, too slow for me, right? Other issues could be related to heterogeneous tech stack. If we have one application or one database that is used by multiple applications, one is written in JavaScript, other one is in .NET, something else is in Go, we have some reporting solution using the same database, and then we want to modify schema of the table, right? So we want to add a column, drop a column, or change the column type or whatever else, right? When we test things locally, we always just test with the latest version of our database, right? So there is no way for us to figure out there is a problem like with migrations. I mean that migration, that there is some old version of some other data application that is not expecting those changes to be in place yet, right? So any changes in schema, it's like, this is very, very risky. This can also be if we interoperate with other technologies through the database, because when we say, let's take like geocoordinates, or even let's take string literals in database, right? We have a thing that is called collation. Collation is basically the order of characters. So when you compare two strings, the order of characters or casing of characters, that matters, right? But now if you configure that stuff and you use it with your ORM in your beloved language, you may have completely different behavior like in string comparisons than in some other language, right? Your unit tests are checking all of that, but only in your programming language, not in all the applications, right? So there are many, many other issues that we all like run at some point in our career. We faced them at some point. We know they happen, but we don't have any decent tooling to figure out that this is happening and to prevent them. This is just the first part of the story. The two other parts, which are about like, okay, I deployed the stuff. Now something is going wrong. How do I know as a developer that this problem is due to like my query or maybe my operating system or maybe, I don't know, Windows update or something else? How do I get the tooling that gives me specific insights showing me where the problem is, especially if I host, I don't know, multiple databases on one DB server, right? So those are like two sides of the same coin, actually, that we have problems with databases. Some of them we find earlier, some of them we found later, but we don't have efficient way of troubleshooting and root causing them.
Yeah, so I mean, that's you made a lot of good points there with really good examples. So I mean, I heard like a couple of things. I mean, one obviously is tooling. I mean, that's one of the issues. I mean, the other one is, I don't know how the proper way to phrase it. It's lack of either planning or knowledge of your tech stack. Because I mean, the stacks are very complicated these days, right? So it's not, you're not seeing the forest for the trees. You're just like a laser focus on one area. So, I mean, are those sort of the main things, or is there anything else that I missed? Like I mean, maybe I oversimplify things, but
well, generally,
yeah,
your description is correct, right? It's
yeah,
not necessarily those things, especially that now world has changed. 10 years,
hmm
15 years ago, we had like one DBA that was managing one database or a couple of them. If we were changing something, we kind of knew what's going on, when the deployment happens, what is our life cycle of release management and whatever other stuff. If something breaks, it was much easier for us to pinpoint the stuff. Now, when we have all those microservices, competing technologies, different cloud providers, and like all those things interconnected, it's basically unmanageable for DBAs to own the databases, right? Especially they look from a little different angle. When they see problems, they often like see only the, let's say, infrastructure metrics showing that, hey, your CPU spiked, right? But we need to have those dots connected with what was deployed. And this is the other side of the coin when we are talking to developers, what they deploy, what the release cadence is. And because now we live with microservices and other stuff, the pace we deploy stuff is basically hectic, right? We deploy things constantly. So now when something breaks, untangling the network of connections is much harder, and root causing the issue is basically something we need to learn again. We can't just apply the same tools and the same approaches we had 15 years ago to the problems we are facing today, because those are new, different problems, and we need to have different approach, different tools.
So previously you said like that you had like a DBA managing a few databases, a few developers in the past. But nowadays with more databases, different stacks, how do you see the role of like a DBA? Is it like a developer with some added responsibilities, or is it a separate role, or what are your ideas on that?
Very good question, actually. We saw this transition in software engineering that we learned that, hey, developers develop, but they need to be involved in the deployments as well, right? So that's how DevOps emerged. And DevOps initially was basically about bridging the gap in communication, that we have developers on one side, some sysadmins on the other side, and they need to sit like hand to hand and work closely together when the deployment happens, right? Then it kind of evolved into something we now consider being DevOps. So we have like teams of DevOps or people that are, merging those two words together, right? And I think in the databases world, we effectively need to have something similar, if not the same. We need to have the same approach, and this approach is not only DevOps, right? We have the same problem with ML ops, with machine learning solutions, that we also see that research teams develop something for the machine learning models, but then when it comes to running that in production, it's not as trivial as, there comes the handover, now you deal with that. The same is with databases. It's not that developers can basically hand their code over to DBAs, and now you as DBAs, you go figure how to run it efficiently. No, it needs to be first working closely together, understanding what's going on behind the scenes, how it works, and then maybe something like, DBOps will emerge. But in order to even start this transition, we need to have lingua franca. We need to have common language for both parties. And common language, common tools, common platforms that like both developers and DBAs feel comfortable when using, right? And this is something that we need to build. New tools, new processes, new approaches to join these forces together. Maybe one day it will actually change. I wouldn't be surprised. If you ask me for my hunch, then yes, I guess one day we'll have something like DBOps, just like we have DevOps, MLOps, DevSecOps nowadays. Maybe this will be like even more ops in place, but generally merging these things together and giving the ownership to the teams directly involved seems like a good idea, something we know in computer science now.
All right. So one of the features that we have with our database, TiDB, is that all the schema changes are online. I think this really helps with like the release cadence, to not have like a weekly release where like the DBA rolls out something and rolls back the whole thing if it goes wrong. What are the other things that allow the release cadence to like speed up?
Very good question. Generally, as I mentioned before, we need to push all the checks to the left as much as possible. The sooner we find the issue, the better. And now the problem arises. How we as developers, how can we figure out whether the query I just wrote or my ORM library generated, whether this query is going to be fast enough in production or not, whether it's going to use indexes, how is it going to be executed at all, right? Because we don't know that stuff. And in order to do that, we need to understand and we need to get a tooling that will show us how the database actually executes the query. We need to get that. Once we have this part, then we can actually pretend like we are running this in production and ask the question, what if? And how do we do that? This is a very good question. Nowadays, we have open telemetry, right? We have CNCF-backed, pretty now applied in all the frameworks. We have this solution that is common, that lets us capture traces, spans, logs, and other stuff. For those of you from the audience who do not know what the OpenTelemetry is, it's basically a set of standardized SDKs that let us integrate seamlessly and export logs, traces, and other stuff, showing how our application works. And this works for uniformly across different programming languages, right? So now what we can do is we can enrich this open telemetry with database execution plans. We can ask the database, hey, this is the query. Please, database, tell me how are you going to execute it? Which tables are you going to access? How are you going to join them? What indexes? What operations? How many files you need to scan, etc., etc. So we get this execution plan. And this execution plan, obviously, is from the local environment because we are running this locally. But once we have the plan, we can actually take this plan and see how it would perform in production. Once we get that, we can tell immediately, without even pushing the code to the repository, that, hey, your ORM generated something that is not going to fly well when you deploy this to production, right? And we can also provide experts' knowledge. Let's face it, DBAs very often need to face similar issues over and over again, right? Performance query, what do we do? Well, let's start with indexing. If that doesn't work, maybe let's rewrite the query to get some better performance out of that. And if it doesn't work, maybe then consider changing the schema, denormalizing stuff, caching stuff in different ways, right? But at least some of that is something that we can automate. We can figure out that, hey, you miss an index here. Just configure this index. This is the command which you can take to configure the index. And once you have it, your performance should be much better. You can take Postgres and you can do HypoPG and see how it would work with this index in place, right? Without even creating this index. So those are the ways we can do, those are the things we can do. But in order to do them, we need to get this understanding of how it works, right? So open telemetry, accessing plans, accessing statistics from live database servers, figuring out the distribution between servers, so effectively connecting them together. It's cool that I have this distribution in my local database, but what is the distribution in the production server, right? If I can get those statistics locally, I can be much more confident when telling what is going to work well or what is going to, fail badly in production.
Cool. Go ahead, Daniel. I mean, were you about to add more questions or before I jump in?
No, just go ahead.
Oh. All right, cool, thanks. Yeah, I mean, you made a lot of good points about shifting things to the left and addressing a lot of things pre-production. And obviously, there are things that we need to look at after it goes live, like in post-production. What are some of the typical challenges you see, and what are some of the tools and methods that people can apply to address things after it goes live?
Yeah, again, very, very important topic. First thing we need to understand is while we do develop something which is digital, not necessarily very physical, those things still can rot and can change over time. Why is that? Because imagine that we are implementing a video streaming-like application, another Netflix, right? When are we going to get the highest peak traffic? Probably Saturday evening, right? When people just watch videos in their prime time, as we would call it, right? But when do we deploy changes? Probably during the workday, right? When we are in the office. So now it happens that we may deploy something that seems to be working pretty well, and only later do we learn that, hey, those things are not scaling well enough because data access changed, because the traffic on a weekly base has changed, because we deployed something and now it's running in different country. We tested that with like US data, and now we run things in European data set, and those things generally, we have completely different characteristics, right? So those things, this is something that we need to be aware of. The deployment and like short time after the deployment, even though all the alarms may be green, metrics are perfect, does not necessarily mean that our solution is working well. We need to be able to react to those changing data access patterns, weekly traffic patterns, or whatever else. But the other thingy, which is also important, is that those things change much more over time. Like, because our business grows, because we scale out our user base, we get more and more traffic coming in, solutions we have in place today may not be good enough for the business we'll be running a year from now. So we need to observe how those data patterns change, and this will definitely affect how we organize our database. It may be that today we don't need an index, but a year from now we will need one. But what happens if we get those indexes over time? They basically accumulate, and we'll have so many of them that like modification of the data will be just too slow, because we'll be updating so many indexes, right? So even though we optimized for some particular queries, now we have problem in a completely different place. What if the index was useful last year, but is not useful today because the data changed, right? How about other stuff that, can be addressed or can be related to this thing, that our basically data that we store and process every day, this changes over time. But the other thing we have is related, for instance, to operating systems. We know that our operating systems get more and more complex every day, right? So it is possible that the hardware we used like 5 years with the older version of operating system was good enough, but it slowly deteriorated. Our CPUs increased significantly, and like the CPU load increased significantly and whatnot, right? So again, we need to observe metrics, and we need to understand what is going on and whether our solutions are slowly degrading over time. But the hardest part about that, again, is seeing the outcome after those many changes accumulate over time, right? If we just look at metrics, we don't get the full picture, right? Because those things, we just change them incrementally. Every complex system evolved from a very simple one initially. And because the complexity increased significantly, we have much more data to process. This also comes to monitoring and observability, right? Maybe initially it was good enough for us just to observe the CPU metric and the memory metric, right? But then we scaled out, we introduced more microservices, we introduced more applications running on the same host. We now have patching, security, auditing, reporting, yada, yada. Just looking at CPU, even if it spikes, doesn't tell us anything, right? We don't know what exactly caused this spike. Is this the operating system, application ABC, some update going in? What could that be, right? So we need to turn from monitoring to observability. We need to turn from getting raw signals into solutions that can connect the dots and show us actually the ultimate effect on the system of all those things, composed together. Another thing, just, closing on this thing, is like data quality. It may be that our data quality degrades over time, right? Just because initially we had some null values in our database and that was kind of acceptable, but later on we integrated more systems. We ran enormous ETLs that didn't figure out, hey, that we are mapping libraries mapping fields improperly. So then what happens is, like, we kind of degrade the quality of the system we are having, but we just don't notice it. Because again, it's so gradual and moving, degrading just tiny bit every single day. So getting, again, all those things together and being able to tell what is happening is crucial and unfortunately not trivial over time.
Mm-hmm. Yeah, I mean, I think especially with quality degradation, and along with, I think you mentioned this earlier, because I mean, what ends up happening in a lot of applications, not just data applications, if you don't do things well early on, uh, there's a cost of like redoing the work, like fixing things after the fact, in which and that I think unfortunately we all live through that. But what are some of the other costs, like in addition to quality issues and rework costs? Like, what are the other costs of not using monitoring tools early on, or thinking about things early on as you develop applications that could sort of manifest over time?
Well, obviously there are things. When we say cost, one of the costs
Mhm.
which is obvious is money, right? When
Mhm.
we degrade, when the quality degrades, we'll just keep
Mhm.
paying more and more for infrastructure, for monitoring, for network bandwidth, other stuff, right? So cost measured literally as money is the
Mhm.
important factor. But the other
Mhm.
cost we also may face is, hey, if we degrade the performance to some extent, will, for instance, impact SEO, like, right, search engine optimization, right? Google will basically position us lower in their ranking score, meaning that we'll get fewer users. Our user base will decrease because of that, right? The other thingy, the worst that may happen, is data loss, right? So if we lose data for whatever reason, because like transactions start timing out, or
Mhm.
because we have quality degradation could lead to that, because we are like losing some data just because we don't notice it's like turned into null values, right? Generally, any data loss that we observe is terrible for the business. So it's like when we say the word, what is the cost? Like the cost could be that we go out of business. That's the worst case, right? But measuring the cost is not as trivial as we may look at it, right? Sometimes it's easier just to pay money, throw enough gold coins on that, add some machines, and we are good with that, right? But sometimes, just paying more or just not noticing the problems happen may lead to things that we won't be able to untangle and won't be able to figure out that the like lower user base is because people felt frustrated with our system and moved on to something else to stop using our platform just because of the performance, right? This is something we won't see on any Excel spreadsheet and Excel report.
Cool.
Yeah, and I think that might also like change over time when it comes to efficiency, etc. And if efficiency goes down slowly, users start to get bored, and yeah, that will be a very important thing to keep tabs on.
Exactly.
Yeah, I mean, some of the things like happen very like slowly initially, right? And then it kind of snowballs. But I think the trick is to sort of spot them early enough that you fix the issue until, I mean, before enough users and people come screaming. So
Exactly. It's basically
yeah.
about connecting all those dots together, right? Just starting with prevention, not pushing wrong code to production, but also
Hmm.
then observing and troubleshooting the stuff, realizing that, hey, your performance degrades, your CPU spiked because you stopped using index, not because you changed the configuration, but because the data distribution changed and this index is not useful anymore, right? Connecting all those dots and seeing like end-to-end effect on all that is happening is important, not only from the technological standpoint, but also from the business perspective, right?
All right. Cool. Awesome. Yeah, I mean, definitely, once again, Adam, I mean, appreciate your time. Enjoy the conversation. And I think for people in Europe, you'll have a chance to meet actually both Daniel and Adam. I'm recording this in early August 2023, but I'm looking at the event page on September 6th. There's going to be a joint meetup between PingCAP and Meta's teams in Amsterdam. Daniel, hopefully I'm pronouncing the name of the hotel correctly. Is it Folks Hotel? Hopefully I'm
Yes,
pronouncing that
correct.
correctly. All right,
Folks,
cool.
yes.
All right, so in Amsterdam, so yeah, September 6th between 6 to 9, you'll have a chance to meet both Adam and Daniel and other folks as well. So I'll include the URL to the page on the podcast description so people can and sign up and attend. So yeah, I mean, so we can continue this conversation. The last question for you, Adam, that we've been throwing at all the participants. I believe you're the first person that we have as a guest joining from Europe. So I know you're in Krakow, Poland. I mean, tell us a little bit about Krakow, what you like about the place. It could be your favorite restaurant or every place you need to relax at. Like, what are reason for people like me I've never even been to Poland? Like, what's the reason for what would be the good reason for me to come visit Krakow? So,
That's always a good question. What to
yeah.
see when you come to a place? Obviously, we have some historical landmarks like Wawel Castle, and obviously the Old Town, or the downtown, as you would call it in the US, which is very like old and has this historical vibe. But the thing is, like, you need to find some places that really gives you something unique, right? And one of the places, especially when it comes to fooding place, is like the place is called Pod Wawelem, which translates to English into like next to the Wawel Castle. And this is a dining place which is kept in this old style from like 50 years ago, where you can actually see this vibe that was before, like when communists were still here years back. You can go to the restroom and listen to some dad jokes from that era. So this is actually really cool. You can eat fantastic Polish food like a big pork chop, and by big I mean something like 3 pounds pork chop. So generally, yeah, this is the place to go to, get this kind of a vibe that is pretty unique to this place. So definitely I would recommend that. Apart from that, we have actually tons of fooding places from around the planet. So any cuisine you may be a fan of, you will probably find it here easily. And also we have really nice museum of arcade games. This is not something necessarily super unique. There are museums like that in many other places. This one in Krakow is really cool. So if you want to play some old pinball, some old arcade games and other stuff like that, it is really cool, worth visiting.
Awesome. Well, you sold me. So a 3-pound pork chop did it. So yeah, and I just realized.
Let me interrupt you here. If you are a big fan of a big pork chop, then next to Krakow, like 10 miles from Krakow, there is a town called Wieliczka. It has a salt mine over there, but also that you can find a restaurant over there which has, and let me do the math real quick, 14-pound pork chop. That is 1/4 pork chop. So if you are a big fan of that and Pod Wawelem is not enough for you, feel free to take it out.
There you go. Sounds awesome. Wow. So it sounds. I don't know, Daniel, if you've been to Krakow, but it sounds like a good place to hang out. So
yeah, it looks sounds really good.
Cool. Yeah, and I was about to say, like, before closing, like, in addition to the meetup, as you mentioned, Adam, I mean, both of our companies are members of CNCF, so you can probably find us at KubeCon or other CNCF events around the world. So cool. Yeah, look forward to have a chance to meet with you in person. Thanks again for your time, and we'll see folks during the next episode. Thank you.
Thank you.